It's rather going in the direction hacky software development. So basically, you want to make sure that the technical part of the team has the capability to build prototypes and ship very fast, because it's no longer a necessity that you have this very deep knowledge of how to train a foundation model to work as a foundation model. The best analogy is web technology. Web technology per se is an incredibly difficult topic. Cache sizes, loading billions of different devices and configurations. Getting this right is quite complex, but you have the abstraction layers in between. AI, foundation models, to use the same analogy, also an abstraction layer, and this means the actual competition no longer takes place on the model level, but what do you do with the model?
Welcome to Let's Talk About Tech, your podcast on venture capital and private equity, brought to you by Venionaire Capital, the entrepreneurial partners. Today, it's my great honor to introduce you to one of the brightest people in AI in the European Union, Clemens Wasner. Great to have you.
Thank you very much. And to the audience, good morning, guten Morgen, and ohayo gozaimasu.
Clemens, you are founder of EnliteAI, chairperson of AI Austria, spent around 10 years in Asia, obviously speak Japanese. Tell us a bit about your background. How did you get to the sector of artificial intelligence?
That's a long story, but let's say I tried to compress the arc as much as possible. I think what really drove me into, let's say, Japanese culture and so on was that my aunt, let's say on my aunt side, I have a very large part of the family that is coming from Italy originally. And in the 80s and 90s, Italy and France were the first two countries in Europe that imported Japanese popular culture at a very large scale. So this happened, for example, in Germany at the end of the 90s, at the beginning of the 2000s. This was 15 years earlier. So for me as a kid, it was quite normal to grow up with samurai and ninja and Mazinger robots. And
Did
not
they
so
have
much
manga back then?
Yes. As well, for example, Dragon Ball came already in the 80s to France and Italy. I think Dragon Ball was the first time shown in German free TV at the end of the 90s. So it was really a gap of more than 10 years. So for me, it was always quite normal to grow up with Japanese culture, and Japanese culture very early on led to video games, to home computers, to education, let's say, in a technical high school in computer science. Then when it came to picking a field to study at university, I chose computer science, which was like the obvious choice, but also Japanese studies. And yeah, so this is, let's say, the educational background. Upon graduation, I always tend to say I switched to the dark side of the force. This means management consultant. So because I really wanted to spend some time on the ground in East Asia. By then, I also had already done a couple of internships in China. And so from 2006 until 2016, I joined the Austrian consulting company. Originally, they were looking for one person to go for 3 months to project to Tokyo. This turned to 7 years in total in Tokyo and 3 years in Beijing. So became partner, built up the Asian practice, and so on and so on. Taken together, I must say, this did not have that much to do with artificial intelligence, at least in the 2000s and the early 2010s. What really shaped and shifted the discussion in Japan was the self-driving car from Google. It's before Google even made the spin-out called Waymo and so on. It was part of Google X. And the very first prototype was shown in 2014, the one that looks like an egg, so it doesn't have a steering wheel and so on. And the Japanese media back then compared this event with the oil shock in the 1970s, because one must also consider that the memory was still fresh, that Samsung and LG were overtaking Sony in market capitalization and market share for consumer electronics. And by the time the 2014, also when we talk about smartphones, the homegrown smartphone market was basically dying out, and it was all about Android phones, again, Samsung, plus of course the iPhone. So with this in mind, people were looking at the car and were thinking, oh my God, does this mean that in the future the software will come from the United States, like Android, like Windows, like Office? And the hardware, it might come from China in the foreseeable future, but midterm, long-term, Southeast Asia or Africa. So long story short, this led to quite a shift in the perception of both electric vehicles and IT, or let's say AI in the Japanese industry and politics. So Japan developed its own AI strategy. Toyota opened their own R&D center for autonomous driving in Silicon Valley, where they put almost 1 billion into it. So it really marked a big shift. And yeah, I think for China, the same moment was AlphaGo in 2016, when AlphaGo beat the Google program that is using reinforcement learning, beat Lee Sedol. That was 30 years ahead of the schedule most people envisioned, because you have more than 10 to the power of 60 different combinations. So people thought it would be possible, but maybe one day in the very far future with quantum computers. And that this happened in 2016 really this turned the industrial industry in China sort of upside down. So they committed back then already 300 billion until 2030. This number now is perhaps tenfold since then. Yeah, good. What has all of this to do with me? So let's say I was there in Asia, having a computer science background, and I see left and right the people are putting it's like at the poker table, 5 billion, 300 billion, 1 trillion. I come back to Austria in 2016, and to put it mildly, there was not that much fever and enthusiasm for AI in Austria. So the first thing I did was having a look which ecosystem players actually exist. So I started to meet lots of startup founders, talk with academia and so on. And in around summer 2017, I back then released the first version of the Austrian AI Landscape. This is again something I was used to in Japan. If you want to do some business research, you just go to an industry organization and they have this type of landscapes, they just give it to you. So back then, the keen interest started what is going on in Austria. To my surprise, there was actually much more going on than I would have initially assumed. And the logical consequence was that I also want to do business in that field. So we incorporated the company in 2017. We were originally a services provider. This means, what is a services provider? One third PowerPoint means AKA strategy, 2/3 implementation. But the midterm goal was always to go in the direction of productization, develop software as a service business. That's why then around 2 years ago, we raised a seed round, and now we are under the label of an AI venture studio comparable to the German Merantix, just a little bit smaller, of course. This means produce AI ventures with a repeatable process.
Do you go in a founder's first approach? So do you find first the talent and then add the problem to it? Or do you always have a proposition of problems that are basically brought in by founders who are willing to take on an endeavor?
See, this is the difference between a mathematician and a consultant. In consulting, there are no problems. There are only business challenges. Now, we find the business challenges first. Let's say for initial market validation, and then afterwards we bring in the founders on board or the product managers and so on. So we try to start as much as possible in the hard tech space. So originally, for example, we dealt with reinforcement learning, the aforementioned reinforcement learning we use for network optimization. When it comes to computer vision, we tried out, let's say, sensor fusion models, which are also quite complex but have the immediate feedback from the industry, and then afterwards, let's say, go into the application, build together a founding team, and create eventually the spin out. But this is a process like 12 to 18 months. It's relatively quick.
This whole AI space accelerated massively with basically an open source research paper, I believe, by Google, the GPT paper, right?
Yeah.
And Sam Altman picked that up, obviously, quite smart, right? And started a huge company and just made a paradigm shift happening. So everybody suddenly was interacting and working with AI. What is the today's state of AI in your perception?
That's a very big question. Maybe a little bit of historic context. The first AI boom, or let's say in recent times, the first AI boom, or let's call it the first AI wave, happened between 2012. This is when Andrew Ng presented the cat pictures and the convolutional neural network. And let's say then you had a couple of breakthroughs like image recognition, AlexNet. You had LSTM, RNNs for translation services, think of Siri. You had Amazon Alexa, and so on and so on. Basically, you can say this happened until 2021. Looking back, if you look which technologies were actually in use, it's anomaly detection. Think of intruder detection, online fraud, and so on. Think of forecasting and time series analytics. This means everything related to logistics and finance, and the aforementioned computer vision, from radiology and let's say relatively complex things to object recognition, like is this a cup or is this not a cup? But what all of these have in common, they were B2B applications, and 9 out of 10 times they were around pattern matching. This means you train the AI on something, and then it gets better at recognizing a pattern. Why I'm telling all of this background related to wave 1 is, at the end of the day, end customers don't really care how is the intruder detection happening or which algorithm is used for quality detection. It's a B2B solution that is totally invisible. So that's one thing. The second thing is, although with pattern recognition, you can do quite a lot when it comes to, let's say, get additional revenue, improve pricing, and so on. Again, the vast majority was just for increasing efficiency. So I would say AI first wave was, let's say, stuck or limited through this couple of factors. What is now very different in wave 2 is that it basically out of the door started as a B2C product. And it started and it took off so extremely because it's using an interface, or let's say a metaphor we are used to since search engines already. So you have one line in the computer, you type the computer what you want. 20 years ago, that was Google, like I'm looking for a doctor, I'm looking for an investment or whatsoever. Now you get even more information out of it. So people, I would say, have been trained with this type of interface paradigm for the last 20 to 25 years. And GPT was for many people a shortcut to Wikipedia or to Reddit. So I think, and it's very end consumer driven. And I think what this means for the enterprise is quite interesting. The aforementioned wave 1 systems were typically introduced top down. So a company would look at these business processes and also its P&L, to have a look which line items or which processes could I improve with AI to, I don't know, reduce indirect cost at 5% or logistics for 1.5% and so on and so on. What is happening now is it's almost, I would compare it with the first software as a service wave 15 years ago. Or shadow IT, as the IT department would call it. There is an incredible amount of knowledge within the organization already on an employee level. These employees, most of the time, do not have an IT background, but this is also not necessary at all. But it's basically turning the tables how AI is introduced in organizations, and I can see it's also changing the way, let's say, investors and startups are approaching the topic, because in wave 1, there are, for example, AI landscapes for logistics startups worldwide, and you see, wow, they have hundreds of companies, but at the end of the day, they work at seven distinctive problems. Now, with the bottom-up approach, this has broadly diversified.
And now the investors landscape has also shifted, as we don't demand startups anymore to have proprietary tech, right? So basically on the main layers, you usually, at least I myself, right, I'm looking at middle layers that are proprietary, right? And then on the application layer, like what we can do with it and how do we treat our customer better? How are we more cost efficient? How are our business models better? Not sure if that's a market standard already, but maybe you can enlighten us a little bit on that.
Enlighten us is a nice wordplay. Now, this is absolutely true because, for example, I'm involved in quite a number of due diligence processes. And it used to be in wave 1 that the typical founder team almost always looked the same. So it was between 3 and 6 people. They were coming either in the United States from an Ivy League institution, or if you look at the United Kingdom, Oxford or Cambridge. So 3 to 6 people, PhDs in natural sciences, computer science, yes, but more natural sciences. And the founding hypothesis of the entire company was built around either a patent application or a breakthrough paper they have written. And so you have this type of companies that, for example, go into the direction of image recognition with a little bit improved convolutional neural network, the same for text, the same for reinforcement learning, and so on. So basically, the bet from an investor's perspective was that there won't be a sufficiently high quality and high number of open source models that you could readily use, like you're used to it from software components, but it stays proprietary, and it will have pay license for it in the future. And this discussion has shifted a lot. But let's say that the pendulum has swung in the other direction now with two things that are happening on the same time. First, foundation models. Foundation models like, the open AI ones are the most famous ones, but they're closed. Let's take the open weight models like Mistral and Llama. You can do many things with them that previously were only possible with closed source systems. Plus, you can do them at a higher quality. Think of anything related to text understanding. Even when it comes to image segmentation, what Facebook is releasing open source or open weight is better than the vast majority of proprietary image models. So basically, you have this gigantic open source wave coming. And it's making it very difficult to really keep an advantage by being just an AI model company. And the switch that I see now in the last 2.5 years is that the composition of founding teams has changed a lot. So I think it's now rather the exception that you have a PhD from natural sciences that is, let's say, the AI model person within the founding team. It's rather going in the direction hacking software development. So basically, you want to make sure that the technical part of the team has the capability to build prototypes and ship very fast, because it's no longer a necessity that you have this very deep knowledge of how to train a foundation model to work as a foundation model. I think the best analogy is web technology. I mean, web technology per se is an incredibly difficult topic. You have streaming, cache sizes, loading. You have billions of different devices and configurations. So getting this right is quite complex. But you have the abstraction layers in between. You have Amazon Web Services for hosting. You have the frameworks like React, for example, that take care of a lot of these aforementioned topics, or let's say Amazon databases and so on. And AI foundation models are to use the same analogy, also an abstraction layer. And this means the actual competition no longer takes place on the model level, but what do you do with the model? So being able to ship very fast, to iterate very fast, this is now really became a core criteria. Also go much deeper into the domain. This is also something. So I would say during wave one, you would say, I built the best image recognition model for this disease nobody has ever heard about, but I built it and nobody else will be able to do it because training models is hard. Then around 2 years ago, it became a bit different. And then you would have companies that would say, look, we are this founding team of 5, always a prime number, I learned. We are this founding team of 5 people, and it's very important. Let's say we use large language models to help processes for doctors. Very unspecific, because it was, to quote the great Forrest Gump, large language models were seen like a box of candies, and you can just do whatever you want with it, and good things will happen. This is a little bit like the Homer Simpson plan from the .com bubble, if you remember. Offer free internet access, ? Profit. And what we see now recently in the last 12 months is you no longer have this very broad approaches to tackling problems within one sector. Let's stay at the example of doctors, but rather you pick 1 or 2 processes and you really bring on subject matter experts. Here then you have the PhDs and so on, which really tell you from A to Z what needs to be done in that process so that it really brings a value to the doctor.
This is a nice bridge to a question that I actually have like waiting, right, to place. It's more about creating value, right? But we're used to charging licenses. So value-based pricing is the big elephant in the room at the moment. What's your perception on value-based pricing?
That's actually interesting, because I mentioned before, I spent a very long time in consulting, and value-based pricing in consulting only worked in certain markets. So, and in certain topics where you can really make a correlation between the output, what the consultant is doing, and the business figures. So think of sales or logistics and purchasing. This is where it works. In strategy, I wouldn't even know how to measure this, because sometimes you have 5, 6, 7 years later the outcome. But let's say there is these expectations that for certain things you can do value-based pricing. Now, what does this have to do with software as a service and AI? Software as a service, let's say AI started in the same way as software as a service. So basically all the tools cost the same, the $20 per month, plus minus. But with 20, you can get Gemini, you can get Grok Advanced, and so on and so on. Where it now gets interesting is that a couple of companies like OpenAI, or now also the Venionaire AI from China, are saying, no, actually, we want to charge you by the outcome that the system is providing. If this is wishful thinking or not, I think for sales, you can make a point. You can also make a point when it comes to customer service and so on. So everywhere where it's easily quantifiable, and we have short feedback loops, I think it will be tried. If it will be successful, is of course it's a whole different cup of coffee. But I think one data point that, in my opinion, makes me bullish on the theory is there was this long form posting from Andreessen Horowitz that was written in 2021. It was called The New Business of AI. It was written, like 12 months into the COVID pandemic, and around 6 years after Andreessen Horowitz started to make big ticket investments in AI companies. And they said, now looking in the rearview mirror for the last 6 years, there are a couple of things where AI companies are very different from SaaS companies. So the initial assumption was you eventually have, let's say, zero marginal cost. You arrive at the profitability between 50, 60, in some cases 80%, and so on and so on. And you have a moat. Turns out none of these three things the AI companies where Andreessen Horowitz invested in had any of this. So they said the moat is not here because the open source models we had earlier in the discussion, they are just coming left and right. They compared it with the TIE fighters at Star Wars. They say it doesn't matter how your roadmap looks like. If your open source model comes, you have to replan everything. So much for the moat. When it comes to the cost, you constantly need retraining of AI systems, and this one model that generalizes for everything does not exist. So,
plus, you have extremely high cost on energy consumption, right?
Exactly. So let's say, long story short, AI and one size fits all SaaS model seem to be fundamentally incompatible if you want to have more, let's say, sophisticated functionality. So yes, on the agent level, I could totally imagine if you think of Salesforce or Microsoft or SAP, that they will start to charge you, let's say, 100, 200 euros per month for certain types of agents. And because the other option would be that you have to drastically increase the subscription price, and you can increase the subscription price because we are now shifting also from pre-trained models with gigantic effort, which are relatively low effort when it comes to the inference, like on your own computer, phone, and so on. But now we go to inference compute, or let's say runtime compute. Again, there's a comeback also of reinforcement learning. And here, this is getting more and more. So the thought or reasoning steps, I think what we see now is just a preview of things to come. And you need to find a way to charge for this. And value-based pricing, if you have short feedback loop, is definitely one of the ways how this can be done.
To maybe wrap this up, right? Yeah. There's one element missing. When talking about AI, we always have to talk also about the hardware infrastructure, because that's the limiting factor ultimately. There is Moore's law, there is the high energy consumption, there's gigantic cooling systems. I can highly recommend attending Supercompute in Atlanta. You will learn a lot about cooling systems, not so much about semiconductors, unless you cross the path with somebody from Germany that has just introduced the world-leading photonic chip. And that was mind-blowing for me. What do you see happening in terms of architecture and computing technologies on the horizon?
That's a very interesting question because, we in the pre-discussion, I learned both of us are semiconductor nerds. And I remember when I gave the first talk about AI in semiconductors, back then everybody was very bullish on neuromorphic chips and new architectures like graph core and so on. Then, of course, you always have quantum computing on the horizon. But now I would say the horizon is getting nearer. And I would say more or less everybody is agreeing with that one. And photonic chips. And photonic chips were back then, I think IBM was already backing it since quite some time, but with a moderate investment. So I talk here about the end of the 2010s, like 2018 and 19, they put like 50 or 60 million into it. But if you compare it, let's say, to neuromorphic computing, photonic was the exception. And the big assumption was always that eventually NVIDIA would struggle to keep its position because tailor-made chips would just, let's say, push away GPUs in the same way as GPUs became the successor of CPUs for matrix-heavy workloads. Now, just a couple of years later, it's interesting to see neuromorphic chips basically are almost gone. I think there's nobody is raising very large amounts and say, I will build a new architecture on the inference side. But photonic computing really became a thing, as they like to say in the United States. So you have now a couple of companies working on this one. And I think what makes it so interesting is that, let's say, from its physical requirements and the way a photonic computer works, it really looks like it was tailor-made for AI. Matrix multiplication, you don't need to be on the latest node size to have a speed up and a very, very low power consumption. And power consumption will be the big bottleneck in the foreseeable future. So it's not a coincidence, for example, that the big European investments tend to happen in France because their energy is cheap, is coming from nuclear power and is extremely plannable.
It's for those who are interested, I highly recommend Q.ANT.com, company based in Germany, in Stuttgart. They have their own pilot line, their own foundry, and it's really impressive what they have built. And they actually have a photonic chip that you can buy and plug into your computer. PCI 6 Express card, believe it or not, could make your computer, if you want to afford it, a supercomputer just at home, and you can start playing around with it. This, I think, definitely is one of the biggest changers in AI. I'm very much looking forward to our next talk. I hope we don't have to wait too long for that. Developments are fast enough. I hope you guys enjoyed our talk today. It was great for having you. Thank you for tuning in. Don't forget to subscribe to our channel, and please tune in for the next episode. Thank you, Clemens.
Thanks for having me, and goodbye.